Hello, this is Susan Paz. This is still section 5.4, and this is the second video. I'm going to work through these pretty quickly here because we just did some examples in detail. This is just kind of a combination. You'll notice the first example here is subtraction. You should always look for that operation first. You need to know if you're adding, subtracting, multiplying, or dividing. You can see that I made the necessary sign changes there in the parentheses that follows the subtraction operation. And now I'm simply going to go through and look for the terms that match and combine their numerical coefficients. If it doesn't have a match, I just write it down. So we end up with a second degree trinomial lead coefficient negative 15. The next example, notice, is an addition operation. So there will be a removal of the parentheses, but there will be no sign changes here. And I'm going through and looking for the matching. I see some matching fifth degrees. Got a stray mark here. Let's get rid of that. I'm looking for the matching third. I don't see any fourth degrees, so I'll come down to the matching third degrees. And I don't see any second degrees or first degrees, so I'll go all the way down to the 0 degree or the constant. So we end up with a fifth degree trinomial whose lead coefficient is 4. And again, I'm just saying this to review some things we talked about earlier. Sometimes you'll see these problems arranged vertically, which is kind of a nice way of getting yourself organized. It's almost like a matrix. So you have a column here of third degree terms. You have a column here of second degree terms. You have a column here of first degree terms, and then the constant or the 0 degree terms. So you just add down. Notice that we keep the same variable with the same exponent. The only thing that adds up here are the coefficients. And this one has a 0 term, a 0x, and we don't write that down in our answer, so I'll just write down the 3x cubed plus 2x squared plus 12, and we end up with a third degree trinomial with a lead coefficient of 3. And this next one, which is also set up in a vertical arrangement, I'm adding down the third degree column, adding down the second degree column, adding down the first degree column, and adding down the constant or the 0 degree column. And you can see that everything zeroes out here, so the only thing that we write down is this positive 9x. So we end up with a first degree monomial, meaning a single term, with a lead coefficient of 9. All right, so that's how they look vertically. So let's go to something a little more complicated, where we have to use the distributive property. The first thing you're going to see me do is multiplying over the parentheses here and multiplying over the parentheses there. So I'm going to tackle that first. All right, so y times y. Now watch, we are multiplying now. This is where you're going to have to be very careful. We are now multiplying, so as we multiply like bases, remember how these exponents add up. So that becomes a y squared. This will take some practice. And then y times 4 is positive 4y. Copy down this addition, copy down this bracket, copy down the 12y. And now I'm going to think of multiplying by a negative y over the parentheses. So this becomes negative 9y. And this becomes, positive, negative 6. And again, y times y, this is a first degree, so we're adding 1 plus 1. So this becomes a 6y to the second. So this is where I'm concerned that you've got to be careful. When you're multiplying like bases, you add exponents. When you are adding like terms or subtracting like terms, the exponents remain the same. All right, for the next step here, I'm focusing my attention right here inside these brackets, and I'm noticing a couple of terms that I will call like terms. Copy, copy, go ahead and combine those two. Sorry, that should not be a negative. You cannot combine this one because he is a second degree y, which makes him different from a first degree y. Notice right here the operation in front of this is an addition operation. So as I remove those brackets, I'm getting a little crowded here, there will be no sign changes because of that addition. All right, so I'm noticing, let's see, here's a y squared and a negative 6y squared. Let me squeeze this in here. This is going to become a, that's not right. It's going to become a negative 5y squared. And then when I come in here and combine the positive 4y with the positive 3y, those two are alike, I end up with a positive 7y. So we end up here with a second degree binomial, again, bi meaning two terms, with a lead coefficient that is negative 5. All right, last one. Again, I've got some complicated things going on here. I'm going to go ahead and distribute inside the bracket first. So copy, 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 multiply, multiply, copy. Now within the within the brackets, I was about to say parentheses, within the brackets now I see some like terms. So let me go ahead and do that. Copy, copy, combine, combine. So you see how I'm working inside the bracket. Haven't moved outside, haven't done anything with that subtraction operation yet. So here I go with my subtraction. This is a subtraction in front of a bracket. This is going to require these signs in here to change as I remove the brackets. So copy, this starts out positive, reverse, this starts out negative, reverse. Maybe I should highlight those in red. So what was positive became negative, what was negative became positive as I removed the brackets. So making those sign changes there. And then finally, I see a couple of like terms here. Let me go ahead and combine those. And then here is a 0 degree term, which I will not combine. This ends up to being a first degree. And I'm going to do some abbreviating here. A first degree binomial, two terms, with a lead coefficient, you need to get your vocabulary going here, that is equal to positive 3. The reason it's first degree, remember, is there's an understood exponent of 1 there. So it's a first degree binomial with a lead coefficient of 3. All right, we're going to stop there.